Let us continue atomic structure. In this, we will see energy of electron. Energy of electron formula is E is equal to minus 13.6 Z square by N square electron volt per atom. Electron volt per atom. Now we will take hydrogen atom. We will take for hydrogen atom atomic number is 1. For hydrogen atom atomic number is 1. That one we will substitute. N is equal to orbit number, first orbit, second orbit, like this we will substitute. So now we will take first orbit. N is equal to 1. First orbit. For first orbit we will substitute here 1. Atomic number for hydrogen 1 we will substitute. We will get energy of electron in first orbit, that is 13 minus 13.6 electron volt. Next we will substitute N is equal to 2. N is equal to 2 we will substitute. We will get energy of electron in second level minus 3.4 electron volt. Then N is equal to 3 we will substitute. N is equal to 3 we are substituting. We are getting energy of electron minus 1.5 electron volt. Then we are substituting N is equal to 4. N is equal to 4, let us substitute. We will get energy of electron minus 0.8 electron volt. Like this, if we go on substitute, at last we will get N is equal to infinity. N is equal to infinity we will get. For this energy of electron is how much, means 0. 0 electron volt. So we got like this. Now you say in which place energy of electron is least. Energy of electron is least. Energy of electron is least in which place? In which place energy of electron is least out of this? In the 1, 2, 3, 4 like this, in these levels, in which level energy of electron is least, do you say? Many levels are there here. Okay. Now hydrogen, if we take it is having 1 electron. It is having 1 electron in the sense how many energy levels it has. Hydrogen is having 1 electron. Its nucleus has 1 proton. Around this nucleus, how many energy levels are possible? How many energy levels possible? Do you say only 1 energy level, or 2 or 3, or infinity? What do you say? How many energy levels possible around the nucleus of electron, around the nucleus of hydrogen? Okay, how many energy levels? How many energy levels possible? How many energy levels possible around the nucleus of hydrogen? Okay, sir. Now this energy level is how many possible? For which let us see hydrogen spectrum. In the hydrogen spectrum, many spectral lines present. Hydrogen spectrum has many spectral lines. In that place we said hydrogen electrons go to various energy levels, isn't it? Therefore only we got many spectral lines in the hydrogen spectrum. Yes or no? So how many energy levels possible around the nucleus of hydrogen? Actually only 1 electron only, no doubt. But how many levels we can predict? Suppose this hydrogen atom is absorbing 1 quantum. Then its energy level changes. If it absorbs 1 more quantum, that energy level again will change. If it absorbs 1 more quantum, again its energy level change. So its energy level goes on changing in the sense how many energy levels it has. How many energy levels it has. In photoelectric effect we said if quantum falls on the atom, then electron will be ejected out. For that some condition is there. Electron is ejected out means what? Electron came to the infinity distance from the nucleus, isn't it? Therefore, we can say how many energy levels possible around the nucleus of hydrogen means infinity we can say. Infinity we can say. But actually hydrogen is having only one electron. That electron present in any one of the levels. Any one of these levels. Like that we can say. Sir. So around the nucleus of hydrogen, infinity number of energy levels possible. Now, as per Niels Bohr, we will find the energy of those levels. Okay, energy of those levels we will find it. Now you are asking what is energy level? You are asking that what is energy level? You are asking, sir. What is energy level means this electron. Now we will take hydrogen atom. What is energy level? You are asking. Now we will take a nucleus. It is a nucleus of hydrogen atom, and the electron is revolving around the nucleus. Electron is revolving around the nucleus. Sir. Now this electron will have energy. Will have energy. That energy. This is having energy. It is present in this place. This place is called energy level. This place is called what means energy level. Now, if you suppose you are giving one quantum to this. You are giving one quantum to this. If you give one quantum, this electron takes this quantum, then what will happen means its energy varies. Yes or no? Energy varies. So it will go to this place. It will go to this place. Now it is having energy. It is having energy. What about the energy of this electron when compared to this electron? Here see, this electron is revolving around the nucleus. It is having some energy. This place is called the energy level. Now, one quantum falls on this electron is observing this quantum, so its energy rises. Therefore, it came to this place. Now it is having energy. Now you compare energy of this electron and this electron. How the energy will be there? We can say here energy is more, here energy is less. Anyhow, this place is having energy, therefore it is called energy level. This is called energy level. So it is one energy level, it is one energy level. This energy level is having higher energy, this energy level is having lower energy. So now you say that how many energy levels possible for an electron? Suppose you are giving another quantum for this. You are giving another quantum. If quantum falls on this electron takes this quantum and its energy again increases. Again increases means it will go to another energy level or not? Now see, it is going to another energy level. Now nucleus is there. It is one level we said in here. Here we are saying this level. Now we supplied quantum, therefore again the electron has gone to another energy level. Like this, if it goes on changing means, like this changing means, how many levels possible do you say? How many energy levels possible do you say? Shall we say energy level C infinity? Otherwise, it is fixed. Shall we say energy levels infinity? Shall we say? Why we have to say infinity in the sense now we will take hydrogen atom. If we supply sufficient amount of energy, then it will lose its electron. Then it will lose its electron and it will become H plus ion. This hydrogen, if we supply sufficient amount of energy, it loses its electron and becomes H plus. Now electron came out from this atom in the sense what is the distance between this nucleus and this electron? Infinity only, no? Distance between nucleus and this electron infinity in the sense this electron present in the infinity level. That is the meaning, isn't it? So shall we say infinity levels are possible around the nucleus? Around the nucleus? Okay. Now we have taken a possible energy levels. So first level we will take n is equal to 1 means first circular orbit, first circular path, first circular orbit, first stationary path, first energy level. Like this you can say. This n is equal to 1. we will substitute here, and the atomic number of hydrogen atom we will substitute. We are talking for hydrogen. Atomic number of hydrogen atom we are substituting, and n is equal to 1 we will substitute. So we will calculate energy. Energy is equal to minus 13.6 electron volt. So when the electron makes first circular path, when electron makes first circular path means what? What is the meaning of that? For that path, angular momentum is how much? Nh by 2 pi. For that path, angular momentum is nh by 2 pi. First circular path means substitute n is equal to 1. Then you will get h by 2 pi. So, which circular path has angular momentum h by 2 pi? That is called first circular path. If this circular path is having angular momentum h by 2 pi, then it is called first circular path. Okay. This circular path is allowed as per Niels Bohr. Between nucleus and this first circular path, there is no other circular paths. This is called first circular path. This is called first stationary orbit. This is called first energy level. Otherwise, this is called first main energy level. We can call this is as a main energy level, first main energy level. N is equal to 1 for this level. Okay, so n is equal to 1 means first main energy level we can say. Main energy level means what? For this subbundle not possible, but this is alone possible. In between these two, no energy possible, no energy levels possible. Sir, so energy level is nothing but energy of electron which is in which is making so and so circular path. That's all. Energy level, main energy level means it is called energy of electron which is making a so and so circular path which has so and so radius. That's all. There is no other special meaning for that. Okay, sir. So n is equal to 1 you are substituting. So we are getting energy like this. N is equal to 2 if we substitute you will get like this. So if we go on continuous up to infinity we can substitute. Sorry, okay. Now you see this. Now you say energy of electron is least in which energy level? Energy of electron is least in which main energy level? That you say. Energy of electron is least in which main energy level? Do you say first or second or third or infinity, or what do you say? Energy of electron is least in which energy level? Here we are talking about which energy in the sense as per Bohr's we are talking. As per Niels Bohr we are talking. Okay. So energy of electron is least in which energy level means in the first energy level. So since energy is least, stability is what? Since energy is least, stability is what? Do you say stability of electron highest, do you say, or least, do you say, or what do you say? Stability of electron is highest. Stability of electron is highest. Okay, since energy is least, stability is highest. Stability is highest. Since stability is highest, this electron is in normal level. Normal level means this is called ground state or ground level. It is called ground state or ground level. So what is n value for ground state for hydrogen? For hydrogen, ground state is n is equal to 1. N is equal to 1 is the ground state for hydrogen and hydrogen-like species. For hydrogen atom and hydrogen-like species, ground state is n is equal to 1. Ground state is n is equal to 1. Okay. Now we will take these energies. We will take these energies. We will take. What is the energy of these levels? What is the energy of these levels? Okay, energy of these levels. Energy of these levels. Shall we say high? Shall we say or least? Shall we say? Can we say energy of these levels least? No, because energy of electron is least in first level we said. So energy of electron in these levels is high. Energy is high means stability is low. Energy is high in the sense stability is low. Stability is low in the sense electron is not in normal position. Electron is not in normal position. Therefore, these levels are called excited levels or excited states. These levels are called excited states, we can say. Excited in the sense, in general also, suppose if anybody getting angry and talking forcibly, then we will say that don't get excitation. We will say no, don't get excitation, like this we'll say. Therefore excitation means what? Not normal, not stable, like this. So here in these levels energy of electron is high, therefore stability is low. Therefore these levels are called excited states, we can say. Okay, so which is ground state means n is equal to 1 is ground state for hydrogen and hydrogen like species. For rest of the levels are called excited levels, excited states. Therefore, for uh, for hydrogen atom, for hydrogen atom and hydrogen like species, ground state is n is equal to 1. Remaining levels are called excited levels. Remaining levels are called excited levels. Okay. So n is equal to 2 means it is called a first excited state. It is called a first excited state. N is equal to 2 means it is called first excited state. N is equal to 3 means it is called a second excited state. This we have to call it as a second excited state. We have to call n is equal to 4. N is equal to 4 means we can call it is as a third excited state. Third excited state, we can say. N is equal to infinity. N is equal to infinity means what? N is equal to infinity means between nucleus and electron is there any attraction? Between nucleus and electron, distance is infinity. Distance is infinity means no attraction. No attraction in the sense nucleus is not attracting electron. So electron is not revolving around the nucleus. That means electron is not in the atom. Electron is not in the atom. Electron is not in the atom. That means, shall we say it came out? Shall we say it came out? Okay. So now see n is equal to infinity. Infinity means what? Between nucleus and electron, in distance is infinity. Distance is infinity means between nucleus and electron there is no attraction. There is no attraction means what? Nucleus is not attracting electron. Therefore, electron is not revolving around the nucleus. That means what? Electron is not in the atom. Electron is not in the atom means what? It came out from the atom. It came out from the atom. So, if electron came out from the atom, then that process is called what? Ionization. That process is called what we have to say? Ionization, we have to say. That process is ionization. So, understand that the ground state is n is equal to 1. First excited state is n is equal to 2. Second excited state is n is equal to 3. Third excited state is n is equal to 4. If electron comes to infinity level, if electron comes to infinity level, that means electron came out from the atom. That means electron has gone for ionization. Ionization means it detached from the atom. It detached from this atom, we can say. Detached from this atom, we can say. Sir, okay. So now we got what is ground state and excited states we got. What is ground state and excited states we got. Okay. Next we will take now we will take hydrogen atom. We will take hydrogen atom. It is in a ground state. We have taken hydrogen atom. This is in which one means it is in ground state. Sir, ground state hydrogen atom we took. Ground state in the sense in this one nucleus is present. Nucleus is present. This hydrogen atom is in ground state. That means electron of hydrogen atom is in ground state. Electron of hydrogen atom is in ground state in the sense electron is in first level. Electron is in which level in the sense first level. Electron present in a first level cell. When electron present in first level, what is its energy? Energy of electron is minus 13.6 electron volt. Energy of electron is minus 13.6 electron volt. Okay. So now you see that hydrogen atom is in ground state. What does it mean? Electron of hydrogen atom is in first energy level. Electron of hydrogen atom is in first energy level. So when electron is in first energy level, its energy is how much means minus 13.6 electron volt. Okay, so energy of electron we got an idea. Now let us give quantum to this electron. Let us give quantum to this electron. This quantum is having energy. What quantum we are giving means this quantum is having how much energy means 13.6 electron volt. This quantum is having how much energy means 13.6 electron volts, so that quantum we will give. This quantum falls on this electron is absorbing this quantum. Okay, so we are supplying this quantum, we are giving radiation to this electron. So this quantum is falling on this electron is absorbing this quantum. Now you say this electron is absorbing this quantum, then its energy becomes how much? We are not talking about actual energy, we are talking with respect to Niels Bohr's model only. Okay, so now this electron is absorbing this quantum, then this energy becomes zero. Now electron energy is how much means zero. Energy of electron is zero. Energy of electron is zero means between nucleus and electron distance is how much means infinity. Distance is infinity. Distance is infinity means this electron came out from the atom. This electron came out from the atom in the sense this atom has gone for ionization. Atom has gone for ionization. Now you say what is the ionization? What is the ionization energy of a hydrogen atom? What is the ionization energy of hydrogen atom? What is called ionization energy of hydrogen atom? It is the minimum energy required to knock out electron from hydrogen atom in its ground state. What is called ionization energy? It is called minimum energy. What is called ionization energy? It is called minimum energy required to remove electron from hydrogen atom from its ground state from its ground state that is called ionization energy. So ionization energy of hydrogen atom, what is this called? It is called minimum energy required to remove an electron from hydrogen atom from its ground state. Now you say what is the value of ionization energy of hydrogen atom? So ionization energy means what? It is a minimum energy. So what we have to do using this energy? We have to remove the electron. From where? From hydrogen atom. In that electron should be in which place? Ground state. Okay. Now see here this hydrogen atom is there. In the hydrogen atom is in ground state. That means electron present in the first level. Electron is in ground state. Its energy is minus 13.6 electron volt. You are giving the quantum. You are supplying the quantum. What energy means? That quantum is having 13.6 electron volt. You supplied quantum to this electron. This electron has absorbed this quantum. Then this electron came to which distance means infinity distance. Now distance between nucleus and electron is how much means infinity. That means nucleus is not attracting this electron. Therefore energy of electron is zero. Energy of electron is zero. This meaning is electron is not getting attraction from nucleus. That means electron is not revolving around the nucleus. That means electron came out from the hydrogen atom. Electron came out from the hydrogen atom, isn't it? Now this process is called ionization. Now you say what is the ionization energy of hydrogen atom? Ionization energy definition is what? Minimum energy required to remove electron from hydrogen atom from its ground state. Now, what is the ionization energy of hydrogen atom? Do you say ionization energy? Ionization energy, you are saying that 13.6 electron volt. So, if we give what energy means, if we give energy is equal to this much, energy of this electron in ground state is minus 13.6 electron volt. If we give 13 this much energy of quantum, if we give 13.6 electron volt energy quantum, then this electron came out from the atom, we can say. It can came out from the atom. It can go for ionization, we can say. Now this electron energy is how much means 0. This electron is at infinity distance from the nucleus. Infinity distance from the nucleus, you can say. Now you say that what is the potential energy of this electron? What is the potential energy of this electron? Potential energy is equal to, what is the formula we discussed? Potential energy means minus k z e square by r. Minus k z e square by r is called potential energy. Now you substitute this r. R is infinity because distance between nucleus and electron is infinity. Substitute infinity. Anything by infinity is how much? That is 0. So potential energy of this electron is 0. Now we will see kinetic energy. Kinetic energy is equal to how much in the sense minus 1 by 2 k z e square by r. Kinetic energy in the sense that is positive value. Okay, so kinetic energy means kinetic energy in the sense what? Electron may revolving around the nucleus with what energy? That is called kinetic energy. Okay, so what is the kinetic energy of electron with respect to revolving around the nucleus? What is the kinetic energy of electron with respect to revolving around the nucleus? That is how much in the sense r is equal to infinity. So distance between nucleus and electron is infinity. That infinity you substitute, you will get 0. You will get here kinetic energy of this electron is 0. This meaning is it is not actual kinetic energy of electron. This meaning is what means this kinetic energy of electron is 0. That means this electron is not revolving around the nucleus. That is one meaning. Another meaning is this electron has not got any extra energy from this quantum. This electron has not got any extra energy from this quantum. This electron has got this quantum energy. That quantum energy is completely utilized to break attraction between nucleus and electron. Okay, so that here kinetic energy is 0. That means this electron is not revolving around the nucleus. And another point is this electron is not having any remaining of this quantum energy. This electron is not having any remaining of this quantum energy. This quantum supplied 13.6 electron volt. That energy is utilized completely to break the attraction between nucleus and electron. That is the meaning. Sorry, okay. So for this electron, kinetic energy 0 we said, potential energy 0 we said, and energy of electron is energy of electron is 0. You are asking that what is ground state? What is ground state? Ground state means one student asks that what is ground state? Ground state means energy. So ground state of electron only we will take. Ground state of electron means energy of electron is least in which level? In which level? That level is called ground state. Now we'll see. You are asking that what is ground state? You are asking. Now you see. Energy levels we have given. When n is equal to 1, n is equal to 1, we will substitute in this formula. In this formula, we will substitute n is equal to 1. And we will substitute z is equal to 1. We will substitute z is equal to 1. So we will get energy of electron is minus 13.6 electron volt. Then n is equal to 2, you substitute here. Z means atomic number. So n is equal to, if you substitute energy, you are getting this much. Like this, you go on substitute n values. Now you say where energy of electron is least, you see in this among these levels, where energy of electron is least, you see energy of electron is least in this level. So energy is least in the sense stability is highest. Stability is highest in the sense electron is in normal position. Electron is in normal position means that position is called, we have to consider as ground state. Ground state means normal level. Normal level. Stability will be highest in that level. So that is called ground level. So ground state means n is equal to 1 for hydrogen atom and hydrogen like species we can say. Sir, now we came back to this place. Sorry. Now we will change this quantum energy. Let us change this quantum energy. Now we will take this quantum energy, how much in the sense we will take 14.6 electron volt we will take now. We have changed 13.6 electron volt previous, now we came to another point. Now we have taken the quantum. This quantum is having energy. Energy is how much means 14.6 electron volt. We supplied. So what happens means this electron is absorbing this quantum, and this electron is utilizing in from this this electron is utilizing this energy to break this attraction. Okay, if it is possible, it is breaking. If it is getting sufficient energy from this quantum, it can break this attraction. Okay, so this electron is trying to break this attraction between this nucleus and electron. Sorry. Now you say that can this electron utilize this quantum and break the attraction between nucleus and electron completely? Can it break the attraction between nucleus and electron completely or not? Here attraction is possible. Here attraction is possible. Between nucleus and electron, attraction is possible. This electron is absorbing this quantum. This quantum is having energy 14.6 electron volt. Energy of this electron in the first level. We are considering hydrogen atom in the ground state. So electron of hydrogen atom is in first level. Ground state means first level. Now you say that can this electron break this attraction completely after absorbing this quantum? Yes or no? Sir. Now this electron is taking this quantum. So energy of electron becomes how much? Okay, first you say whether this attraction is broken completely or not. Okay, now the electron, this attraction is broken completely or not? Sir. So you are saying that this attraction is broken completely. Now this electron and nucleus distance is how much you see. Now what is the energy of electron after observing this quantum? That you say. Energy of electron you say. So now you have to say energy of electron, you have to say energy of electron you say now. Then we have to say potential energy and kinetic energy we have to say. So what is the energy of electron now? Sir, you are saying that energy of electron is 1 electron volt. Sir, you are saying energy of electron is how much in the sense 1 electron volt you are saying. Energy of electron is 1 electron volt. This is a positive value. This is positive value, it is not negative value. Now, what is the distance between a nucleus and electron? What is the distance between nucleus and electron? Now, what is the distance between nucleus and electron? Will it be infinity or not? Distance between nucleus and electron is a infinity, shall we say, or it is not infinity? What shall we say? If you say infinity, then we can say between nucleus and electron there is no attraction, we can say. If you say infinity, if the distance between nucleus and electron is infinity, then we can say between nucleus and electron there is no attraction, we can say. Okay, so now you see that here in this hydrogen atom you have taken in the ground state. In this hydrogen atom, nucleus is there. This electron, this atom is having one electron. This electron is revolving around the nucleus. Now, why this electron is revolving around the nucleus means because nucleus is attracting this electron. So attraction between these two, this nucleus is attracting this electron. Okay, sir. Energy of this electron is how much means minus 13.6 electron volt. Energy of this electron is how much means minus 13.6 electron volt. Sorry, what is the potential energy of this electron? What is the potential energy of this electron? What is the kinetic energy of this electron? That also we'll see. So now energy is equal to what is the formula in the sense minus 1 by 2 k z e square by r. It is energy of electron. What is the potential energy formula? Means potential energy is equal to minus 1 by 2 kz e square by r. 2 is not there, only minus kz e square by r. That is potential energy. Sorry. Then we will see kinetic energy. Kinetic energy is equal to 1 by 2 kz e square by r. It is kinetic energy. Okay. So energy of electron is minus 1 by 2 kz e square by r. Potential energy is equal to minus kz e square by r. Kinetic energy is equal to 1 by 2 kz e square by r. So now energy of electron is minus 13.6 electron volt. Substitute this energy here. Substitute this energy here and take to this side. You will get a potential energy. So now you say, what is the potential energy of electron here? What is the potential energy of electron? Okay, energy of electron in the ground state. Energy of electron in the ground state is minus 13.6 electron volt. Energy is equal to minus 1 by 2 kz e square by r. Substitute this energy here and take this to this side. Then what is the remaining? Means this is the remaining. So you will get potential energy. So what is the potential energy you are getting? Okay, you say, what is the potential energy of this electron? What is the potential energy of this electron in the ground state? What is the potential energy of this electron in the ground state? We will say, what is the potential energy? Because what is the formula? Formula is what? Energy of electron is equal to minus 1 by 2 kz e square by r. In the energy of electron derivation, we got this formula. If we substitute r value if we substitute, then we will get energy of electron is minus 2 pi square m z square k square e power 4 by n square h square formula. We will get it. Okay, so energy of electron formula is this one. Potential energy is equal to this one. Kinetic energy is equal to this one. Kinetic energy. Now energy of electron we got. Energy of electron is this much we got for hydrogen atom. Now you substitute this energy minus 13.6 electron volt, you substitute here. Then can you get potential energy? Here energy is 1 by 2 minus k z square by r. Potential energy is equal to minus k z square by r. So what is the potential energy value for this electron? Substitute this energy here. Will you get potential energy? Will you get minus k z square by r? Will you get minus k z square by r? Will you get it or not? So will you get potential energy or not? So now you say, what is the potential energy of this electron? What is the potential energy of this electron, do you say? Sir. So now we will substitute this energy, we will substitute here. Sorry. So we are substituting, you are saying that potential energy is equal to minus 27.2 electron volt. Then you substitute this value here and get kinetic energy Kinetic energy is equal to, what is the formula? 1 by 2 k z e square by r. 1 by 2 k z e square by r is called kinetic energy. Okay, substitute this energy minus 13.6 electron volt, you substitute here. Then minus sign you take that side. Then what you will get here, you see. Then what is the kinetic energy of this electron, you see. So what is the kinetic energy of this electron, do you say? What is the kinetic energy of this electron? Kinetic energy of this electron is how much? Substitute this energy of electron minus 13.6 electron volt. No, substitute here. Then take this minus this side. Then what is the remaining? 1 by 2 k z e square by r. That is the remaining. So 1 by 2 k z e square by r is called what? Kinetic energy. So what is the kinetic energy of this electron? What is the kinetic energy of this electron, shall we say? This electron, when hydrogen atom is in ground state, kinetic energy we can say that 13.6 electron volt we can say. So this electron, when hydrogen atom is in ground state, the electron is in first level. This electron will have energy